Okay, moving on from the first question. Now that we've established the values of P and Q, it says find the value of the constant R for the equation, which is x squared plus px plus q plus r equals 0, and we're told has equal roots. So let's go ahead and do that. I'm going to do that on a separate sheet actually, but we're going to transfer the values of P and Q over. So let's rewrite this. We've got it here, which is x squared minus 2x minus 15 is equal to 0. So let's add that over on this sheet here. So here it is. So I'm going to write it over here. So we're going to have x squared minus 2x, and we've got minus 15 is 0. But this time I'm going to say plus r is equal to 0. Okay, so we're told that the roots are equal. Now, in order to calculate this, whenever we have a non-numeric value or a non-clear, explicit numeric value as part of one of the elements of a quadratic, we use the discriminant in order to ascertain what that might be. So in this case, I'm going to look at this equation here, and I'm going to divide this up into a, b, and c. Well, a, of course, is the coefficient of x squared, and in this case, the coefficient is 1, so a is going to be 1. So there it is. B, on the other hand, is the coefficient of x. So we're looking at an x to the 1, x to the 2, x to the 1, and x to the 0. This is my x to the 2, here is my x to the 1, and the coefficient of x to the 1, which is b, is going to be negative 2. There it is. It's the coefficient of the x to the 1. Now, the coefficient of the x to the 0 is all of this. Technically, there's like an x to the 0 thrown in there. That's a 0, by the way. Yeah? So the c value is going to be negative 15 plus r, or if you liked, r minus 15. So now we go ahead, we use the discriminant, and the discriminant in this case is b squared minus 4ac. In this case, we have to say what its relationship is in terms of what are the nature of the roots. Well, we're told the roots are equal. In that case, we're going to use an equal sign. If we were told there were no roots, then we would have a less than sign here. And if we were told it had 2 roots, then we would have a greater than sign. So let's have a look at putting a 0 here. And let's now populate the equation with the values we've already established. So in this case, b squared, well, b is going to be negative 2. So I'll put negative 2 all squared minus 4 times a. Well, a is 1 times c. And in this case, c is, and I'll put minus 15 plus r. I'm not able to keep the equals under each other, which was disappointing. Never mind. So I got negative 2 squared is 4 minus, well, 4 times 1 is 4 times, put brackets in there, negative 15 plus r, and put equals 0. All right, so let's now expand this out. Well, I've got negative 4 times negative 15, which is positive 60. So I'm going to have 4 plus 60, and negative 4 times r is going to be minus 4r is equal to 0. So I've got negative 4r, I'm going to put is equal to, I'm going to subtract 64, here's 64, I'm going to subtract 64 from both sides, subtract 64 from that side as well, which renders this not there anymore, equals negative 64. All right, so let's have a look. Well, I'm going to divide both sides now by negative 4r, or negative 4, sorry. So divide by negative 4, divided by negative 4, and of course we're left with r is equal to, well, negative 64 and 4 is 16. So the value of r is 16. So you could rewrite this as x squared plus, and you could put the value of p and q in here, which we already know, and r plus r, and equal to 0, and that would play out perfectly well. Nonetheless, that is the correct answer. Hopefully that makes sense.